So I'm going to solve the same problem with an ICF chart, and this is when you're making an in situ buffer. And so it just means that you're actually doing a reaction rather than mixing two things together, like getting this jar off the shelf and this jar off the shelf and mixing them, like say you maybe don't have one of them or something. You can do this reaction, and the reaction will generate a buffer. We're going to use this again when we do titrations, and there's going to be a whole section of titrations where this basically happens. So you want to be comfortable with it. But this is an ICF chart because this is a final reaction, not a back and forth reaction. So initially, I need to have this whole chart in moles. So initially, for the NH3, this is like saying 0.3 liters, 300 liters, times 2.0 moles per liter. So that means that I've got 0.6 moles of this one. And then this is like saying 0.2 liters times 1 mole per liter. And so that's saying that I have 2 of that one. And I don't start off with any of that one because I haven't made it yet. Notice it's all 1-to-1. So I'm going to be subtracting out, basically I'm going to be subtracting x and adding x, but I look to the top to figure out what is x in this case. And so in this case, 0.2, that's my smaller, between the 0.2 and the 0.6, that's my smaller one. In a sense, what we're saying is we can just look at that and tell that that's the limiting because everything is a 1-to-1 reaction. So what I'm going to do is I'm just going to use that other method where I subtract out 0.2, 0.2, and I add 0.2. So that's going to tell me that I have 0.4 and I have 0.2 and I don't have any of this left, which is good. Now I have my salt, and I can write out that my pOH is my negative log of 1.8 times 10 to the minus 5th plus the log of my salt over my acid, which is 1/2, which is the same thing up there. So I'm hoping you can see what an easier, faster method this ICF chart is versus the old Jing Kim way of doing all this, Jing Kim 1 way.